that. But to build effective large-scale applications, you've got to understand how to use object-oriented programming. Okay, it's not just, oh yeah, a method, that's like a function, right? If you have that approach to object-oriented programming, you will not be able to build anything complicated that will be debuggable and manageable. So that's a hard requirement. At Stanford, that means CS 106A and B, which my understanding is nowadays one of them in C++ and one's in Java. Is that right? So that's 2 languages. You're going to learn a 3rd language in this course because the iOS SDK does not use either of those 2 languages. But it's always good to learn more languages. CS 107, recommended, just more experience. But 106A and B, if you haven't taken both of those or the equivalent thereof, this, of course, can be a struggle. For example, here I'm listing a bunch of object-oriented terms like class, instance, message, method, instance variable, inheritance, superclass, subclass, protocols. If these don't seem familiar to you or you're like, I think I know what that is, this is going to be trouble, okay? So make sure you know those terms. The iOS 4 SDK. So that is, SDK stands for Software Development Kit. That's basically the big package that is the development environment that we're going to use to develop applications. It's free. You can download it from developer.apple.com right now if you want. It's big, but you can download it for free. But to run on a device, if you want to build an application and run it on an actual device, you need to be a member of a program, capital P program. And there's 2 programs of interest here. One is the iOS Developer University program. Now, all of you Stanford students sitting in this room, you're going to get a free invitation to that. It costs you nothing. Once the enrollment decisions are made, and if you're one of the lucky ones who get in, we will send you an invitation to that. And that will allow you don't really get anything more in terms of downloads, but it allows you to run your program that you build on the device. Okay? If you're watching on iTunes or you're in this room and you're not a Stanford student or you don't make the enrollment and you decide to sit in and audit the class, which is fine, by the way, then if you want to run on the device, which you may or may not want to do, if you're building your final project for yourself, obviously we're not going to be grading it if you're not a student, but if you want to run a device, you can pay $99 a year. And for that $99 a year, you not only get to run a device, but you also can submit your application to the App Store and sell it. And so people complain about $99 a year, but think about it, $99 is actually a pretty good deal considering that's got to cover Apple's costs to review your program and pay you, right? When you sell your program for money, they're issuing you a check or paying you, and so there's overhead for them. So $99 a year, that's a steal. And so that's the difference. If you're in the class, you're welcome to do the $99 a year. It's the same thing. And in fact, for $99 a year, another thing you get, access to betas. So as the beta versions of iOS 4.1.2 or 4.2 or whatever come out, you'll get access to those if you pay your $99 a year. You won't if you're in the University Developer Program. In addition to answering the invite we're going to send you, if you're a Stanford student, you can also submit the device ID of your device. Actually, you're going to have to submit the device ID of your device, and we will approve it. And then there's this whole process that you'll go through to get a certificate that you can put on your phone that basically enables you to run your application. And we'll talk about all that later in the year, okay, in a couple weeks, maybe at a Friday section or something. The university program goes on a quarterly basis, so it's only going to be valid for this quarter. But any code you write at the end of the quarter, when this thing shuts off, you can start paying your $99 a year, and off you go. It's not like anything happens. It's just that it won't work on the device anymore after the quarter is over. Okay, so what will I learn in this course? Okay, well, the number one thing you're going to learn is how to build cool apps. Okay, and why do I say the apps are cool on this platform? Well, it's a lot of reasons. One, this is a very powerful development platform. You can build very complex apps with very little effort. Okay, so it's very rewarding as a programmer to put in some effort and, whoa, this is really cool. I got this cool app, in a very small amount of work. So it's rewarding in that way. Also, it's very cool to build an app and say, hey, my friend, let me show you my app, and bring it out of your pocket. That's cool, as opposed to, okay, well, here, I'll give you this CD-ROM. You can go run it on your Windows machine or something like that. Okay, so it's pretty cool that the result of your work lives in your pocket, or can. If you do develop an application that you want to sell, it's super easy to sell it and market it on the App Store. Okay, On other platforms, you're like, what, I'm going to put it in a box, or I'm going to make a website and people order it? No. Here, people have the App Store. Everyone who has a device has the App Store. They can just click, bam, you get paid. It's very awesome. And it has a pretty vibrant and big development community. I mean, obviously, Android developers aside, or not aside, this is a large development community. A lot of people working on apps for the iPhone. And so, you're entering in an ecosystem where there's a lot of exciting jobs out there and a lot of exciting people to work with, okay? But besides building cool apps, learning to build cool apps, you're also going to learn about how to apply object-oriented programming in the real world. Okay, you've taken CS106A, CS106B, you know C++, you know Java, that's great, but now you're going to use that object-oriented programming learning to build apps that you could actually sell. And in fact, many of students who have taken this class in the past ended up putting their apps on the App Store. Okay, a very large number, dozens of them. So that's quite likely. Along the way, we're actually going to learn and review a lot of computer science technologies. This is a computer science course. Okay, we're going to, in depth, do databases. In fact, object-oriented databases on top of relational databases is what we're going to do in this class. We're going to do a lot of graphic stuff, all this other stuff I have in here, multimedia, multi-threading. We do a whole week on building multi-threaded applications. So there's a lot to learn here in this class, not just how to build apps for this cool platform. So here's my really fast overview of what's in iOS. It's so big, I could take 2 or 3 lectures just going through each line item. I've tried to divide it up logically here based on closer to the hardware. So the stuff at the bottom is close to the hardware, and the stuff at the top is close to the end user. Okay? And I've just picked a sampling at each level, and these levels are not hard levels. They kind of cross over each other, etc. But a lot of people maybe don't know that the iPhone OS is basically Unix. Okay, it's Mach. It's the name of the Unix variant. It's a BSD variant. It's the same fundamental kernel that in OS X. And so you got a really powerful underlying operating system that provides a lot of primitives. So this core OS layer got a lot of stuff in there. You see some of the stuff I have in there, like sockets, and obviously you have a file system. Power management is a big key on embedded devices like these, because if you write an app, for example, that uses GPS all the time as you follow you around, it's going to eat up your entire battery really fast. So you have to learn how to, ask for the GPS coordinates on a reasonable, request basis, because you're talking about trying to listen to a satellite. That takes a little bit of energy. So the core OS layer has a lot of mechanisms for doing low-level access. Most of this stuff, not object-oriented, and you're not going to be writing very much code, if any, at this layer. The next layer up is object-oriented, and it covers a lot of that OS with object-oriented interfaces. Okay? So, for example, networking. There are classes in there like socket class and things like that, URL classes for opening up HTML pages. That's all object-oriented at this next layer up. But there's also non-object-oriented higher-level things, like there's a SQLite database on every iPhone and iPad and iPad Touch, so you have SQL available. So you can do pretty serious database-intensive applications on this platform. And then there's other pretty cool primitives at this layer, like Grand Central Dispatch, which is a mechanism for doing threading. That's really cool. We're going to learn that this quarter. And core location I have listed up here. That's like how to find out where you are using not just GPS, but also local wireless Wi-Fi stations, actually. You can look around and see what Wi-Fi stations are around and kind of guess where you are, which is pretty cool. And then even your 3G, by cell towers, it can figure out kind of to a general area where you are. So that stuff is all in this core services layer. I made media right here be its own layer because there's this device, iPhone and iPad, it's an iPod at heart. Okay, so all your music and stuff from iTunes, videos, watching movies and stuff like that, there's object-oriented APIs for doing all that stuff from inside your applications. Okay. And so we're going to learn most of the stuff at this layer, how to record audio, how to record video even into your application, how to display video, how to draw graphics, obviously a lot of cool graphics drawing primitives, etc. So that's the media layer. But the top layer here, Cocoa Touch, that's the object-oriented interface to building applications. It's got things like recognizing gestures, swipes and pinches and all that stuff. It's got very powerful primitive objects like a web view, which is basically an entire browser in a little rectangular area that you can embed inside your application. Okay, entire with following links, everything, images, all that stuff. So core motion, which lets you use the accelerometer and the gyro in the new devices to figure out the position of your phone in space. Just enormous amount of stuff. I couldn't even, this is a tiny fraction, 5%. And it's also where the infrastructure for building the apps is. Okay, and we're going to talk about that in a moment too, that infrastructure. Just quickly covering the components of the platform, the development platform. So these are the things you're going to be using to build the apps. The things I showed you on the previous slides were the things that are on the device when you're running it. Here's the tools you're going to use. So you're going to use Xcode, which is kind of this all-in-one application that lets you do code editing, building, all that stuff, debugging in one place. There's another app, Interface Builder, that lets you wire up and build your user interface graphically without having to write very much code at all. Actually, in the next version of Xcode, Xcode 4, those two applications are going to be merged into one, Interface Builder and Xcode. We're not going to be using Xcode 4 this quarter. And then there's also a bunch of applications in a suite called Instruments that are for things like managing your memory, finding out whether you're leaking memory, analyzing the performance of your app. Why is my app running so slow? Really powerful tools. I wish we had more time to go into those. Again, maybe a Friday section, but they're pretty cool and pretty powerful. Again, new language to learn. It's called Objective-C. It's a strict superset of C. I'll be teaching you that language from scratch. I'll teach you everything there is to know about that language pretty much next week. Frameworks, this is what you might call in other languages, like in Java, it might be a package, you might call it, or a library. These are basically groups of objects, and there's a ton of frameworks, and we'll try to cover as many as we can this quarter. An underrated but really important component of this platform development is this object-oriented design strategy called MVC, Model View Controller. So that's what I'm going to cover in the next 25 minutes, and then we'll be pretty much done for today. Any questions about the platform before I go into MVC? It's pretty obvious. It's pretty early right now. You're kind of probably swimming a little bit in a lot of data, but it'll all become clear to you. So MVC, what is MVC? Okay, MVC stands for Model View Controller.